Hey everyone, I am back. It's been a month, longer than a month, I think, since I've done one of these videos. I've been so busy with uni. Holy moly, it was crazy, but I'm done. The last 8 weeks were just insane. So I didn't have a lot of time to do my own work. I just had to do projects and my thesis and stuff like that. So I formatted my PC. I've done a whole bunch of stuff. I decided to do a short tutorial. I always say short, and they're always like an hour, but a short tutorial to just get my feet wet again and do some of my own coding again and to get my channel active again because people have still been subscribing even though unfortunately I haven't been getting much out. I had started this video like 20 minutes ago and then the postie knocked on the door and ruined everything. So hopefully there's no interruptions this time. I'm going to show you event systems today and why I think they're useful, mostly for code encapsulation. You know, we should always be writing classes that only deal with that internal logic for that class. We should never really be touching too much of the insides of other classes. But I think in Unity we tend to too much, um, particularly when it comes to beginner programmers. At least I did, and I don't know if other beginner programmers do, but hopefully if you do, this will show you a good way to stop that bad habit and make your code A, more scalable, but B, just more neatly wrapped up and less exposed, and you know, everything's all in one place. So I'll just quickly show you my simple scene here. I have an enemy. As you can see, I've already got that highlighted. It has an enemy script on it. That enemy script is currently empty, doesn't do anything. A box collider, and then just a wall. You know, think of this white wall as your environment. It also has a box collider on it and doesn't do anything. My main camera has a simple character controller script, which is also empty. So I'm going to do a very bare bones example of why events are useful, why I think you should use them, how they better keep your code together in a really, really small example. So my character controller is not going to do anything fancy. It's just going to check for mouse input. So the first thing I'm going to do is I'm going to say, hey, I want to know if I click on an object in the scene. So I'm going to say if input.get mouse button down, say mouse button 0, which is left click. Then I'm going to say if physics.raycast, because we want to raycast to see if we've hit something. We'll say camera.main screen point to ray, and we want to say input.mouse position. So this is a very simple piece of code that says if I push the mouse button, fire a ray. Obviously, this if statement will only evaluate to true if the raycast hits something, because if it's null, null is not true, so it won't evaluate to true. Then if it does evaluate to true, I can say debug.log I hit something. Right. So my character controller already has functionality. I can click around. Oh, I'm not clicking on anything. As soon as I click on the wall, I hit something. As soon as I click on the enemy, I hit something. It's pretty cool. Pretty cool for 10 seconds worth of work. We already have some functionality in there, but we can't really do much with that. We can't tell what's going on here. Now let's say I want to know if I've hit the enemy, because when I hit the enemy, I want to take its health down. There's a few ways you could do that. I think I used to use tags. I've been told tags are really slow. You can do special raycasts that ignore certain layers, although that might not always be useful depending on how many layers you want to hit at a certain time. You can check its name. There's all sorts. I'm going to do this probably a really hacky way, but I think for the example it's fine. Is I'm just going to check if the object that I hit has an enemy script on it, because if it does, then it has to be an enemy, right? The wall doesn't have an enemy script on it. So that's the way I'm going to do it. So I'm going to say var e equals, I did this last time too. Sorry, I need to create another variable. So I'm going to create a raycast hit variable called hit object. And the result, where's that one? So basically the result of this raycast is going to be stored in hit object. And that will only, again, happen if this evaluates to true. And I can say var e equals hit objects dot transform dot get component of type enemy. So if e does not equal null, debug.log, we hit an enemy, else we hit something else. So you can see here I've just got a little bit of logic now that says try and get an enemy component from the thing that we hit, which is stored in hit object. If e is not null, then we've got an enemy. We've got the enemy script, and therefore we can say we've hit an enemy. Otherwise, we've hit a wall. So here we hit something else. Here we hit an enemy, and obviously still nothing around the outside because our raycast hit is not evaluating to true. So that's pretty cool. Let's kill the enemy. So I think a really naive way to do this, and probably the way most people do it when they first start learning how to code, is they'll do something like this: public int health equals 10. Okay, and we'll go in here and we'll say debug.log -- e.health. So the minus minus at the front, for those that don't know, is going to pre-decrement the variable. So every time I click now, I should get 9, 8, 7. So I'm hurting it. That's what we wanted to do. That's bad. The reason that's bad is, let's say you want some more logic here. So we could do something like this: if e.health is greater than 0, actually should be greater than 1, really. No, greater than 0. Or we'll do something like this: else destroy e.gameObject. So we've got this logic in here now that if the enemy goes down to 0 health, is it playing? Oh, I've broken something. No, how did I break that? That's fine. Maybe it was working. I just don't have a debug in there anymore. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Yeah, there we go. So it does work. That's okay, but like, why is all this logic in the character controller? It's a bit weird. This shouldn't be in your character controller. Your character controller shouldn't be worrying about that. This is the enemy's logic, not the character controller's logic. Why is it doing that? And of course, I'm checking here for an enemy. This is sort of maybe acceptable in this game if all you're doing is checking for enemies. But what if I had buttons or doors or, I don't know, elevators, anything? Like, I don't want to check every time I click a button. I don't want to check for this massive slew of different objects. Yeah, so that works in this case, but it's messy. It's not very nice. It shouldn't look like that. And why is this public? One of the reasons that we get taught in uni that this shouldn't be public is for this reason. So I can now make this private. I don't need to know about the health, but let's make it so I can get the health if I need it, for whatever reason. But when I say remove health, okay, I just call remove health. Whoops, void remove health. This logic should really be in there. So I can now say if health, God, I'm on a roll today. If health is greater than 0, then health minus minus, else destroy game object. So this version is better because at least the logic for dealing with removing health is actually in the enemy script. it's much better already. We don't have to deal with that because there is a chance that before we had it in here, I can undo this. It's going to error out because it's not public anymore. But let's say my character controller is not the only thing that can damage an enemy. What if there's environmental objects that can damage an enemy? That means every environmental object needs this logic in here as well. So then if I decide I change the way that my logic works for damaging enemies, I have to find every instance of that and change it. Right? So that's why that is so terribly bad. This is already better because at least I only have to change it in one spot if I want to change it. And I can now do something along the lines of e dot remove health and then debug log e dot get health, which is what I should have done before so I could tell that it was working. So now you can see that it still works. Okay, it still works. That's not the greatest code there, but it works. But I still don't like it because, as I've said, this shouldn't really be happening here, in my opinion, because you're checking for too many things, and you shouldn't have to check for any of it, because all the character controller should be concerned with is, you know, the logic of moving the character. So this is a very simple example, but you can imagine a more robust character controller would have its own logic, like, well, can I actually click now? So if this is a shooting game, do I have bullets left in my magazine? Or, you know, is the fire rate fast enough that, you know, holding down the button will still actually let me fire? Yeah, at the moment, anytime I click. But in a game, sometimes even if you click, your action won't go through because there's other logic preventing that from happening. Okay, so imagine that our character controller is doing that. And that's all it should ever do. So we can tidy this up a lot, and we're going to do that through events. Finally, I'm getting to the event bit, and I'll show you why they're useful. So I'm just going to get rid of all of that, because that we don't want any of that there. I'm going to change this around a bit too, but we don't want any of that logic dealing with the enemy in our character controller. It's not useful. So we're going to use delegates and events. Now Unity has its own event system. You use that whenever you're using the Unity UI. I'm showing you the C# event system. This is a very basic implementation of C# events. I've seen crazy ones where people make messaging services and you can like subscribe to message types and all this sort of crazy stuff. I don't think you really need to do that for small games. This is a really simple way of just encapsulating your code a little bit better. So we start with, they always have to be public. We start with a delegate, public delegate, and then we just specify a signature, which is like the signature of the method. So I want a method that returns void. Now we have to name the method type. I always try to follow this convention. So I'm dealing with a delegate that's to do with clicks. Now is this going to be an action event or a message event? Doesn't really matter. This is just how I remember things. So this is a click action event for me, and it takes no formal parameters at this stage. So it's just a void function. This is just the name of the function, method, whatever you want to call it, and it takes no parameters. Okay, so that's the signature that we will be using to subscribe to events. So for those who don't know what delegates are, they're basically a pointer to a whole method or a whole function. So normally we say point to a primitive type like an int or a float. In this case, this is allowing us to point to a whole method. And we fire events based on this delegate and the signature. I just pointed at the screen. You can't see that. So events are also public. I'm going to make the event static. Now the reason I like to make events static is because I can access them statically. So later when my enemy class over here, it wants to subscribe to this event, I don't have to have a reference to my character controller anywhere. Sometimes that would be useful to not have non-static events. As I mentioned before, and I'll talk about later, if you want to deal with extending your character class and maybe a character controller and maybe using it for AI, you won't want static events because you'll have to register, say your AI character controller will register to an AI logic, whereas your player character controller will register to an input logic. And if you're registering to static events, then you don't have that granularity. So they don't have to be static. for the most part, I think they're fairly useful static. Use them on a case-by-case basis. So it is an event, so it's a public static event. Then we name the type of the event. So this is of type click action. And then we need to actually name the event. So this will be on click. And we don't put curly brackets behind that. So we have an event called on click here, which is of type click action. And obviously click action must have this definition for us to be able to register to it. Now, I'm just going to move this raycast variable up here because it's just out of the way. And I'm not going to wrap this in an if statement anymore. So what I'm going to do quickly is I'm just going to, we'll use this later. So I'll just pop this up here out of the way. But for now, I'll just leave it there. So the way we call an event, as we do that, we call the name of the event with curly brackets behind it. And this is going to throw an error. I'm doing this on purpose to show you why it throws an error. So this seems pretty obvious, right? If I detect that I've pushed the mouse button down, then send the event that I've clicked the mouse button. Oh no, I get a null reference exception. The reason for that is nothing has subscribed to this event yet. I've created an event, but no one is listening for that event. I don't have any, I'm not pointing to any functions that I want to call when I call onClick. So as per MSDN, all those places, you just null check the event. You always null check your event. So if your event does not equal null, then fire it. So this basically says only fire the event if something's registered and listening to the event. Because nothing is listening to this event at the moment, this will evaluate to null. And sorry, my phone is not on silent, it just went off. This will evaluate currently to being null, and so it won't fire the event. So this is already much neater because we're not dealing with any logic for any other class now. The only thing we're worrying about is, hey, do we have the ability to click? And as I said, normally there'd be some more logic going on here. But yes, if I detect a click, then send the click. Just let everyone know that subscribe to this event that I've clicked. And that's what we're going to do here. So let's just get those out of the way. They're useful. So we have to subscribe to an event now. We're going to do that on the onEnable function. This is a built-in function as part of the Unity engine. This is the way Unity suggests you subscribe to events. And the reason for that is that onEnable, and obviously by extension onDisable, are always called regardless of how you instantiate, awake, reactivate, deactivate, destroy, whatever. It doesn't matter how you're toggling whether an object is on or off. OnEnable and onDisable always get called. And that way, we always ensure that when we subscribe or unsubscribe from events, that there's never some object left over that's, subscribed to an event that doesn't exist anymore. Or, you're trying to subscribe an object that isn't even awake yet to an event or something crazy. So you always subscribe and unsubscribe your events in onEnable and onDisable. Now, as I've mentioned, this is a static event. I do that on purpose. I don't need a reference to the character controller. I can just say my character controller dot, and the event name is onClick. I don't know if you can see that there, onClick. Now we use the plus equals operator. So I want to add a function to this event. I want to listen to this event. Now, Visual Studio, very nicely, if you can see that there, I can press tab to autocomplete. I'm going to. So what that's done is it's created a new method called myCharacterController underscore onClick, which I really like the naming convention for, and I use. And obviously it throws a default exception because I haven't done anything with it yet. Then what we do is we say on disable. We want to say myCharacterController.onClick. Instead of plus equals, we're doing the opposite. We want to unregister, so minus equals myCharacterController underscore onClick. Now, the reason I like this naming convention is that I can look at this method now and know exactly what it's for. It's for the event on click for my character controller. And all I'm going to do here, which might seem silly, is I'm just going to call that internal method we already have called remove health. Now, some of you might be thinking, why didn't I just subscribe remove health to this? You know, I could have just said, I could have just made this remove health. I could have done it that way, and then, you know, done the opposite down there. That would have worked. But there's a few reasons why I'm not going to do that. There's going to be a bit more logic in here in a minute. And also, as I said, you might have other sources of damage dealing to the enemy. And so you might want the enemy to subscribe to multiple different events, and then just have like a generic method that just deals with removing health. And then you just have this for, I guess, code readability, so you can see, oh, okay, well, this is for this event. Rather than having a generic class and having to scroll up and see which ones you've registered for and then try and work out which method it's calling. I just like it. It's easy. It makes things simple to read. So if we run this now, do you think it's going to work? We don't have any debug statements in there, do we? So let's just say debug.log health. So do we think this is going to work? Let's have a look. It doesn't work. I just clicked in the middle of the sky and the health has gone down, but I didn't click on the enemy. Why is, like, what? Why is that happening? Because I've subscribed to the event, but I have no logic here. I just say every time the character clicks, then remove health. But that's not right, is it? We only want to remove health if it clicks on me, if the enemy, you know, if the character controller clicks on me. And this character controller class doesn't have that logic, and it shouldn't have that logic. It just says send me a click, or send out a click. So, as I said before, the reason I've done this and the reason I've left this line in here is this method here. This is a signature for a method, so I can change the signature. So when I send my click, I'm going to send a raycast hit object with it. So if I push the mouse button down, I'm going to create a raycast object. That could be null if it hits nothing, but it will be a raycast object. And then if something is subscribed to this event, I'm going to fire that event, and I'm going to also send my ray with it. So coming back in here, you'll see I now have an error because this method header no longer follows the same signature as my click action. It also needs a raycast hit. Now we're fixed. And the reason I like keeping a generic method for removing health down the bottom is I can now add some more logic to this. So I can say if hit object dot transform equals transform, then remove health. So this is a simple way for me to pass a raycast object, and instead of worrying about looking at tags or dealing with layers or doing something funky, I just send the raycast out to every object that's subscribed to it. So if I have like 20 enemies, they will all run this method when that event is called. They'll all say, hey, did that raycast just hit me? And if it did, if it hit one of them, that one will remove its health. The other 19 will go, oh, well, it didn't hit me, so I won't do anything. Of course, if I don't hit any of the enemies, then they'll all just do nothing. You can imagine that would get, if you had a lot of objects that were clickable in a scene, that could get pretty crazy with the amount of checks that you're doing every time there's a click. So you might have to find ways to optimize that. But again, this is just a good simple example. So now if I run this, I can click anywhere, it doesn't do anything. As soon as I click on the enemy, it loses health. It keeps going down and down and down and down and down and down. And my bad code gets, there you go, it gets killed. Should probably die at 0 health, really. What is so great about this code is that this character controller doesn't know anything about the enemy. It doesn't care about the enemy. It just knows that it needs to, when you can click, it needs to send out a click event. This enemy doesn't know anything within reason about the character controller. It knows one exists because it's subscribed to its event, but it doesn't have any reference to it. It doesn't care what the character controller is doing either. In fact, the only thing it cares about really is, oh, hey, did the character controller click? Yes, okay. Well, under what circumstances do I have to run code if the character controller clicks? Well, I need to know if it's clicked on me, that I need to remove health. Otherwise, it doesn't need to do anything. And you can see very quickly how in a very dynamic game that has lots of systems, how you could very easily start adding lots of different events here in onEnable and onDisable, and just have these small chunks of code that deal with that one specific event case. It's really powerful. It's really simple. The enemy has no reference to the player. It's not trying to interact with the player. The character controller, sorry. The character controller is not interacting with the enemy at all. Whereas in our first iteration, the character controller basically did all of the enemy's logic, which was really bad. Really, really bad. And this works really well. You can now extend the enemy. You could add events into the enemy. So when the enemy dies, it could fire an event down here as well as destroying itself. It could fire an event, and your UI could be listening to that event so it can update score. So you don't have to have a reference to your UI anywhere in your enemy script. You just call the event. The UI hears that event and updates the score. How awesome is that? If this character controller was more robust, you would get rid of this obnoxious line here because that is horrible. Why are you hard coding looking for mouse 1? You shouldn't do that. You can obviously use Unity's axes and that sort of stuff if you're the type of person that likes to reinvent the wheel like me and try something, rebuild something just to know how it works. You would abstract all your input as well from this character controller and you would make an input controller. I'm on my desktop right now. If I was making a touch game, I could just hard code a bunch of my keys and my mouse to simulate touch events. Left click could be a touch, right click could be a hold. Click and drag with the mouse could simulate a swipe. Okay, but I could just send input events. So I could just send, a touch event, or a hold event, or a swipe event, or a pinch event, or a zoom event, just with keyboard shortcuts. But my character controller will just intercept those events like it normally would. And then I've got the ability to rebind. So later when I actually want to test on device, I just comment out the lines that were checking for keyboard input, and I uncomment the lines that look for touch input. I don't have to touch my character controller then. I only have to update it in one place. But even better than that, if I want to make AI, I have a character controller that already works. So why would I rewrite another one? I can't reuse this character controller because it's got hard-coded checks for input. If this instead was a check for an event, or I subscribed to an event, then I could reuse the same character controller for an AI. I would probably, instead of throwing a static event, I would throw a non-static event, and I would have my AI logic send out specific events, and my character controller could deal with that. And that way I could reuse my character controller and have different, it could have it listening to different events. Or rather, sorry, to make that more clear, my input class would have a non-static event, and the player-controlled character controller would register to, say, the input controller's events, and the AIs would probably listen to an AI controller's events. The AI controller throws exactly the same event types, it just has different logic. But I can reuse the character controller. And that's something you couldn't do if you didn't use events and you didn't abstract some of this stuff out, which is why I think events are really strong and really handy. So anyway, that's just a quick overview on how to use them. You need a delegate. With a delegate, you provide a signature, so that is the return type, just the name of the function, and any formal parameters. You then create an event based on that delegate type. You null check the event to make sure something is subscribed. If that evaluates to true, you call it with any formal parameters that need to be associated with that delegate. Classes that wish to subscribe to that event, subscribe in the onEnable and unsubscribe in the onDisable. You can register any function as long as it matches the delegate signature, I like Visual Studio's autocomplete version, actually, to be honest. And that's pretty much it. It's really simple. I hope you guys enjoyed this. This is my first tutorial in like just over a month, so sorry if it's a bit all over the place. I'm also testing different software for cutting up this video, so hopefully it goes okay and uploads okay and you all like it. As usual, please subscribe, please give me some feedback. I've been getting a lot of views on my other videos, but I haven't been getting a lot of feedback, so I don't know if I can improve on these, where I should improve. If there's anything you guys want to see, please let me know. I'll try and work it out. I might do a tutorial maybe Monday even on some simple mesh creation, just like creating simple planes or lines. It's pretty easy, it's pretty fun, it's actually pretty useful. So let me know if that's something you're interested in. Otherwise, thanks for watching, and I'll see you all again in a few days.